Hello, everybody. I'm really honored and happy to be invited by Shining 3D Dental to participate in the Learning Lounge from Scan to Smile. My lecture today will be about 3D printing. Short brief about me, I'm Dr. Sameh Shaaban. I'm graduated 2001, Mansoura University, Egypt. I have a postgrad from University International de Catalonia and also diploma of membership of Royal College of Surgeons of Ireland and Edinburgh. I am now operating a private practice in Mansoura, Egypt. Also, I am a consultant locum in a private practice in Kuwait. So let's start our topic today, Chairside 3D printing excellence, redefining one appointment dentistry. One appointment dentistry was a dream for many years for many practitioners all over the world that we can establish our treatment in only single visit for the patient. This dream was begun by Professor François Durin in 1973 in Paris. His PhD thesis is about this topic. From this simple drawing, he has a strong belief that good indirect restoration is far better than anything else. So he succeeded finally to bring his innovation to light, and we can see the first scanner, first software, CAD software, and he successfully milled the restoration for the patient in one appointment from composite block. Okay, his innovation is taken furthermore by Werner Mormann and Marco Belenstini in the University of Zurich for producing the actual or the commercial prototype from the scanner and the milling machine. And moreover, the Sirona takes this innovation and release the Seric one in 1987 to be the first one appointment system. Actually, if we see the from this year 1987, there is many limitation of the system, closed system, very high initial cost. Not everybody can afford the system or can market the system for himself. Although the system was very nice, but it is not widespread. Till 2018. 2018, many scanners appeared from this time, which is very good, very accurate, and in the same time, affordable price. So let's review the conventional processing of single visit restoration versus digital processing. The conventional processing is simply taking impression, putting the impression into models and making the restoration on the model, taking this restoration from the model and cementation intraoral. So versus digital processing, which emerges from 1987, taking an optical scan, going for the CAD software design, and then going for the CAM software, nesting this design for the milling machine and the milling from different blocks. Uh, maybe hybrid ceramic, maybe the lithium disilicate. There is a lot of brand of the blocks available for the milling machine. So what happened is also 2018, one company get approval, FDA approval to use its printer and its resin to be used for printed processes. So the game changed now. The digital, not only one way versus the formative manufacturing or the conventional processing. Conventional processing remains the same. Yes, there is a lot of modification in direct to composites and properties of direct to composite, but the digital processing become two ways, milling or printing. So, what is 3D printing? 3D printing simply is building the 3D object layer by layer. So, what we use 3D ceramics or 3D printing ceramics in? We can use it in dental, like us, medical application, aerospace, automotive sectors, jewelry, fashion. furniture, internal design. So there is a lot of application. We only part of a small of this industry. And the type of printer we use for the application is depend on the form of the material. So if we use a liquid ceramic, we can use like us in dental industry or dental sector, uh, GLP, for example, the type of the printer. But also we can print a powder. We can print a solid material, but by different type of printers and for another application purpose. Okay, why we use the additive manufacture? Why not only milling, and why we introduce or the company introduce the subtractive manufacturing, which is the 3D printing for us? Let's review some limitation of the subtractive technology, which is the milling, consuming excessive material. Yes, we we just mill a very small restoration from a large block or disk. So there is a wasting for the material, and of course, on our expense. This material, wasted material, it is not free. It is on our expense. We throw it out. Unusable wastage, yes, we talked about this because the waste, we can't use it. We just throw it away. And it has an environmental issue also because we consume the resources without using it um, uh, efficiency. Limitation in reproducing details and complex geometry. Yes, uh, to reproduce a geometry, we are depend on the diameter and the shape and the material of the milling pair. So if we want to reproduce a very nice detailed crown, for example, we need a very fine diameter pair, which of course will not be durable and will be expensive, and um, this make limitation also in the geometry because how far can be this pair can be thin? How can 0.1? Okay, if we need a geometry less than zero point 0.1, how can we reproduce it? So there is a limitation in the issue of complex geometry. High tool wear. This wheel is consumable. This wheel is had a cost, and it add for the end cost of the uh, processing itself. Okay, if we compare the subtractive, which is milling, to additive manufacturing, which is printing, we can make a mass production. We can print like 20 crowns in the same time, but in milling, we can't do this. We mill crown by crown. So this results in reduction in the manufacturing time, reduction in the raw material wastage, because we build layer by layer. So the wastage, we will use it again. We will not throw it away. Facilitate the production of complex geometry. We depend now in the diameter of light, not a diameter of tool. So we can reduce the diameter of light to nano, to micron, to whatever we want, but there is a limitation in the diameter of the pairs. Control perverters during the manufacturing process. Yes, we can control a lot of perverters, and we will see in our application and more later in the end of this lecture in the future of this 3D print. We can control more parameter than ML. Okay, let's see this picture. A lot of crown, they take the same time as one crown. As long as the length is the same, it takes the same length. In milling, no. We mill one, then mill the another. It take a lot of crown. Sometimes printing one crown take more time than milling one crown. But if we compare milling 8 crowns, 10 crowns, and the printing 10 crowns, it will be a very different issue. The printing 10 crowns will take very less time than milling them. So, what is 3D printer and are all printers the same? We have two categories nowadays. Printer manufacture compatible product like Shining 3D. Uh, Here, it make a printer, it make a washing machine, it make a software, it make a query on it, it give you a parameter. So it is like ecosystem. Anything printer, it's commercial printer, industry printer, it can get it from Amazon, from anywhere. Okay, so we have two categories, and the most of question come to me. Should I invest in more expensive compatible systems or should I go for anything printer, which is the initial cost is much less than compatible product? But the issue is is completely different because printer manufacture compatible product means that they make a compatible verification or verification for the reason this printer can work with. So they give you a complete workflow, a complete parameter, and they design the printer for for your purpose, which is manufacturing crowns. They not design the printer to make toys, to make something not biocompatible. They design everything to be working in your industry or your workflow. And the setting is set by the manufacturer. Everything we will see in uh, the through the lecture. But anything printer, you means X brand resin, X brand printer, um, X brand slicing, so Y brand software, Z brand curing unit, Q brand washing machine or washing protocol. So how can you manage and make everything is compatible? They are from different manufacturing. They are manufacturers. They are from different manufacturer point of view. Maybe sometimes different manufacturer purpose. So you want to make them all work together, which maybe it work, but it is not so easy in our daily workflow. So compatibility is the issue. You buy the compatible system or you go to make the system compatible. You make everything to be compatible with others. Like in this video, viscosity velocity. The resin of hybrid ceramic is really viscous. If you buy a commercial printer, they didn't know what the viscosity of resin you will use. So they will not design the printer to print viscous material like this. But if you go with dental printer, they verify or they knowing what kind of resin you want to print at the end of your day. So they design everything to be compatible. There is a lot of parameter we control in our printing issue, like exposure time, lifting height, lifting speed, lowering speed, delay. This is the most common things we control in our printing parameter. But you can do it by yourself, trial and error, if you go for anything printer system, or if you are like me, which want a predictable and a reliable result every day, you go for a compatible system. Compatibility is the main purpose to using a dental 3D printer, not anything printer. Like in this slide, I use a 3D printer from Shining for they give me a ceramic platform. And ceramic platform for hybrid ceramic is very important for the maintenance of the stability of the color. Because when I tried the aluminum plate for it give like a grayish color in the resin. The waste resin in printing, we use it again and again. So when there is an interaction of aluminum particles with the resin, it makes the resin in the first it fantastic in the first 5, 6 times of printing, but in the 20, 25, in the same resin, you find the resin become grayish. So the dental or the compatible system, 3D printer system, they know what type of, they know that the color will mean a lot for you, not like others in sync printer. So they develop a ceramic platform. And also, as I told you, because we need to print a viscous material, they include a built-in heater in this ceramic platform. So the heater, not only in the platform, also in the tank. So we had like in F1 in Shining 3D, we have a dual heating uh, action in the resin, in the tank itself, and in the platform as well. Slicing software is another compatibility issue. When you buy a system from um, a dental company, they give you the software, which very pretty easy in Shining 3D with AI nesting. It give you the best optimal nesting position in only mm, maybe 1-2 minutes. It become very easier for you to work, not like uh, anything uh, softwares. So we are speaking that the hardware is compatible, the resin is compatible, and also the resin is verified by the hardware and also compatible software. But the most important thing in Shining 3D system, it is work with any another reason. So it is not a closed system. No, not only you should use the Shining 3D resins, no, they are cooperate with the most major resin manufacturer all over the world to include the resin in the system. So it is very important for us because we are not depending on Shining 3D R&D research in the resin. We can there is a lot of company or resin company in the world which produce a very nice and very reliable resins. We can use it in the Shining 3D, and it includes a parameter and the values for this to be the best parameter and the best values to print this resin in the printer. You just make update for the your printer, you find a lot of material days after days, week after weeks. Even if you ask the Shining 3D to include a material you like, they get a sample from this material and they make a verification and send you a result and include in the printer system. But the journey is not over yet. It is not only printing. Because many people sometimes invest a lot of time to understand the printing issue, but printing is only the first part of 3D printing, final 3D printing. We need the strengths and we need aesthetics in our workflow. So the post-processing procedure is very important as well as 3D printing itself. We should pay attention for the post-processing procedures the same as printing. Not to invest a lot in 3D printing and making post processing as a simple or not a issue, not a big issue. No, it is a big issue. And we will see the best protocol for cleaning and curing. So post processing is cleaning and curing. First cleaning we can clean by chemicals or we can clean by mechanical way. Chemical, mostly we use resin which should be cleaned by alcohol, which is a solvent for this resins. For these resins, alcohol is three types of alcohol is available: methanol, ethanol, and IPA. We can't use methanol, of course, it is toxic, so we can use only ethanol, 95%, or IPA, which should be more than 90%. 91, some countries had a concentration of 96% or 95%. or maybe we go higher for 99%. Okay, ethanol is very nice option, but it is not widely available in every country. It's a natural um, uh, alcohol, by the way, but also IPA is very good option for cleaning our printed hybrid ceramic printed restorations. I strongly recommend only 90%, 91. I not recommend using 99 because it is very strong. It's very time sensitive application. Smell and sensitivity for skin is very high. So I am comfort to use 90% concentration IBA. Okay, cleaning maybe with alcohol, with brush, ultrasonic cleaner. Yes, it's good. Or using a washing machine. Washing machine can be anything washing machine also, as we speak about the printer. Or you can use a 3D dental washing, 3D printer company brand like Shining in this example, washing machine. The washing machine is designed to cut your restoration from the platform and to clean it with parameter, with time, with uh, temperature required for cleaning the material. Same software. Yani, it means like if you print in the Shining 3D printer with X brand resin, you go for the washing machine knows that you already used this material. You just select the same material in the washing machine and select cut and wash. It cut the restoration from your printing plate and begin the washing according to the manufacturer of the resin time. If the manufacturer says the washing is 2 minutes, 3 minutes, it do the same time as the manufacturer recommends. We can use also mechanical way for cleaning uncured resin. There's two ways of mechanical cleaning using air abrasion and bead blasting. In my opinion and my experience, sandblasting is very dangerous for 3D printing, and 3D printing material is very sensitive for this aggressive type of cleaning. I prefer the glass beads cleaning because it is very gentle. Sorry. It gave us a very clean surface. At the same time, it didn't remove any layers or very minimal layer of material. It also make a surface enhancement for the superficial layer of the material. So glass beads is the best. You can see the comparison between the glass beads particles with a spherical, and it is not sharp like the sandblasting aluminum oxide material. So after we finish the curing, the cleaning and the drying, we should cure. Why we should cure? Because the material will be sticky and cured resin on our printed object. Still present, incomplete polymerization potentially affect the object mechanical properties. So the object is not fully cured. We had a superficial layer which is partially cured, and we should remove this most superficial layer. And for the issue of biocompatibility, we'll use this resin and mouse of our patient for many years. How come we give them something which is not fully biocompatible? And uncured resin, unfortunately, it is not a biocompatible, but cured resin is biocompatible. Also, there is constant or there is a problem of finishing and color stability of incomplete cured uh, resin. So we get the most or the best mechanical, biocompatible, and most aesthetic finish if we fully cured uh, our 3D printed object. What we use for curing, of course, UV, ultraviolet. Ultraviolet, as we know, is separated to UVA from 315 uh, wavelengths, nanometer wavelengths to 405, and UVB and UVC. The wavelengths we use for the curing of our resins are 3D printed 3D printed hybrid ceramic restorations is from 315 to 405. So we achieve the best material properties biocompatibility by making uh, final curing for our restorations by putting the restorations in UV light box. Of course, the time of curing depends on the manufacturing of this UV box. And again, we will back about the compatibility system. If you buy a printer from X brand, then you wash in Y brand, then you cure in Z brand, and you use Q resin. What give you the parameter? Who is responsible for reliability and all these parameters? Nobody. Somebody who buy for you the printer told you he will help you, but he will help you for some time for one reason, but not for life. But again, when we are an 3D printing company, and we get a validated UV box from them, they give us the printer for every validated resin they recommend us to use. So we are in ecosystem of printing, cleaning, and curing, not to be lost like anything printer issue. Okay, it's very important to buy a UV box which is 360 rotation, because if you buy something which is not has this option, you should make rotation for your restoration, which double the curing time for you, which may affect the physical properties of your printed restoration, may affect the color stability. So simply, it is very strongly recommended that your curing had a 360 rotation. Of course, this light cures is not a good option because it is not suitable in the wavelengths, in the strengths, in the proximity of the light source to your printed restoration. It will not give you a biocompatible static or best mechanical properties of your printed restoration. Dr. Ahmed Hassani and IDD make a very nice comparison of different brand and different curing unit, and we can summarize the technology or the methods we use to cure our 3D printed restoration using a UV box alone, and we put our restoration in glycerin bath to make oxygen inhibition layer for fully curing our restoration, or for the same purpose to make an oxygen inhibition layer, we can use a water bath light cures, and we can use a vacuum, um, another light box which is working with vacuum technology, vacuum pump to withdraw the air from uh, the light box, so we can make an oxygen inhibition layer uh, final curing of our restorations, or we can use the nitrogen light cures. So basically, there is four ways: the normal light box, and we use glycerin bath to overcome the issue of oxygen inhibition layer, or we can use water bath or vacuum or nitrogen. Of course, uh, about the nitrogen, which is the most modern and the most nice way to make our curing, we have also a sub-classification of the source of nitrogen. Sometimes it is self-generator, light cure box, or it is a separate self-generator which come with a UV box, like the middle brand, or there is a nitrogen which come in tank, and then you you make everything attached to each other, like in AutoFlash or Sirona and Shining 3D. So the source of nitrogen is different. Also, the concentration, the pressure is different between the all brands. We will not go deep because this issue need a webinar in itself. But every company believe that it adopt the best option for itself and for their customers. So if you compare the UV light only without anything, it's very simple. But as I told you, there is the most superficial layer of your 3D printed restoration is not fully cured, so it is not fully mechanical properties, not fully aesthetic, not fully color stability, not fully biocompatible, not biocompatible restorations. So the next step, we use a glycerin bus. As I told you, it is a very efficient way, like we use in direct composite restoration to make an oxygen inhibition layer, and we can use it with the UV light box. Water bus vacuum is also alternative to make an oxygen inhibition layer, and nitrogen, it gives us the most optimal result as an oxygen inhibition layer. So we basically, if we, the most reliable thing to use your UV box with affordable entry level of curing with glycerin bus. The second best option will be nitrogen UV box. This is the most modern or the most consensus technology about post-processing curing. So I divided the screen into the left one, which was EcoFab, EcoCure, FabCure 1, FabCure 2, which is affordable prices UV box from Shining 3D. We can use it, yes, with 3D 360 rotation, with control of our timing of UV. Of course, FabCure 2 is had a temperature and had a more powerful wavelengths. We can use it with glycerin bus. But if we can go for FabCure N, FabCure N is uh, more expensive and it use the nitrogen technology. Why nitrogen? Simply, Shining give us this slide. It compares the different color stability of splint or aligner, which is clear. And if you want to see color stability in something clear, you challenge your curing process because something clear is more sensitive for the color stability. And you can see the difference between nitrogen curing and another alternative curing methods. And of course, it's documented that the nitrogen curing give us the best uh, color stability uh, in the post processing. Okay, what can I use my printer or 3D printer? We can use it in many applications in oral surgery to fabricate a guides, in prosthodontic to fabricate procedures, orthodontic aligners, or braces, positioning trays or guides, many things. Endodontic, there is a guides for calcified canals, perio for perio guides, tissue harvesting guide. We have a many applications. There is no limitation um, for using 3D printer in your clinic. You can imagine and you can execute or develop your purpose or your application. There is no imagine, there is no limit. So what can I do with a 3D printer? Our topic today will focus, of course, on prosthodontic. And the prosthodontic, as I told you, 2018, it is the first printer to get approval from FDA uh, for using as a permanent restoration. Bigo also received its clearance from FDA later on 2020 for using the resin as a permanent restoration. So this market from 2018 to 2028 expected to be a very large to reach approximately 8.29 billion. So it's nothing small, or it's a huge business workflow, and you will see a lot of innovation and a lot of improvement in this workflow. And in the same time, the companies are 3D printer industry predicting that chairside same-day dentistry using printer will becoming a norm. 2028, it's not something far away. It's just like 3 years, maybe less than 3 years, and we will be in 2028. We will see. For myself, one appointment in dentistry using 3D printer since 3 years ago, it become a norm for me. I use it a lot, and we will see in the clinical cases. So 3D printing application will be divided into fixed restoration and removable restorations. Of course, we will focus about the fixed restoration because of time of this lecture. Chairside fixed restoration with printer. It can be one appointment in dentistry, or same appointment in dentistry. We can give the patient lithium disilicate oxide, oxide ceramics, and hybrid ceramic as well. Of course, we are talking today about one type of one appointment dentistry, which is hybrid ceramic. Why especially hybrid ceramic? Because low cost of the material, low cost of the equipment. Of course, it can be printed easily. Sustainable production don't require treatment like ceramics, glazing and staining like glazing and staining of hybrid ceramic. You can do it with UV box, not in ovens and furnace like other ceramics. Modulus of elasticity of this material is less brittle than ceramic, and we will uh, talk about this issue more later, about it is advantage or it is disadvantage. Can be used without layering. Most of the user of the 3D printed hybrid ceramic use it as a monolithic, not a layered option. Yes, it can be layered by composite, by conventional composite, by lab composite, but the the issue, or the main purpose of using it, it's using as a monolithic in less time. So is printing the most question I had asked it for many times, is printing hybrid ceramic resin is a longevity fact? It's actually a long term. Sometimes some people told me it is a long term temporary. No, it's a permanent. It's not a company promotion or a company force. It's a permanent option for you and for your patient. Don't don't think it is a temporary option or a long-term option. No, we can use it for, of course, as a temporary or as a long-term temporary. But if you use a good methodology and good machinery, workflow, and good reason, you can use it, of course, as a permanent restorations. So we will talk about some point about flexure strength, adhesion degradation, and wear resistance and biocompatibility, trying to discuss with you if it is a permanent restoration or not. Flexure strength, some material in the market. The company make a research for breaking load after 10 years of shearing simulation. And we can see the result. There is a drop from the flexural strength from 1250 to 1024 after 10 years of shearing simulation. It's not a big drop, and also this drop is still far away from the shearing force, which is 720 Newton. So it's durable to be last in our patient mouse for more than 10 years. If we see the result of flexure strength of the most common resins we use for permanent restoration, about to be 150 megapascal, which is very nice, which is far away from the enamel itself, far away from the porcelain layer in the PFM restorations. Of course, PFM itself as a metal has a higher number of flexure strengths, but the veneering ceramic layer is less 100 megapascal. So you give our patient a, a monolithic material with flexure strengths about to be 150 megapascal. Oh, another issue. What about cementation durability? There is studies also to measure the durability of making cementation with resins, with flowable, with high filled flowable, of course, with heated composite, and as we see, the most of the material it is very durable in the cementation. And micro CT analysis of cementation after 10 years of showing simulation, it tells us there is a very little degradation of the cement force after 10 years of simulation, 2.6% only, which give us the conclusion it is a very durable uh, material. What about wear behavior? Of course, the wear behavior of our hybrid restoration is more than lithium disilicate, which is less than zirconia. So the wear resistance of zirconia is the best. Then it comes to lithium disilicate, it will be in the middle, and the highest wear behavior will be in the hybrid ceramic. But what about to see the opposing? The opposing wear in the zirconia is the highest. It gives us more than 20%. And in the lithium silicate in the middle. And the least wear behavior in the opposing is opposing hybrid ceramic restoration. What do you prefer? What do you prefer the wear happen in the restoration, which you can replace after 10 years, after 15 years, after 20 years, or it happen in the teeth itself? And you need to make a restoration for it. So if you calculate or you sum the wear of the restoration itself and the opposing, you find that the wear resistance is the best for the hybrid ceramic restoration. It is not for lithium disilicate or for the zirconia restoration. So don't think about using zirconia of 1000 megapascal, 1020 megapascal. No, it is for another purpose. It's used for full arches, for Bontex, but we are talking mainly about one appointment in dentistry for a lace, for endocrowns, for a small bridge, 3 unit at maximum. So we don't need this aggressive material to be in our patient mouth and to make wear for the opposing natural dentation. You can see this case. This case come to me 3 years ago after raising the bite for her and after making a 3 unit crown for her upper anteriors after only 3 years. What happened for her lowers? Yes, attrition. And if we compare the attrition opposing for zirconia crown and the attrition opposing natural teeth, you can see it is fourfold more, full four, four-mold more attrition opposing zirconia. If it is hybrid ceramic crowns, I I can imagine that this attrition will not be too much like opposing zirconia crowns. Biocompatibility, it's a big issue. As I told you, we give the restoration for a patient forever. So it should be very biocompatible. We fear using plastic as a permanent restoration because we know the issue of microplastics contamination, while plastic plaques clogging our artery. And there is a global awareness about decreasing the use of resin in our drinking bottles, in our everything. So how can we use it in our mouth? So it big it gave us a very warning about to be sure about the material we use. We should verify the source of the resin. We should verify the certification of this resin. We should verify our workflow. We should verify our every step of post processing. If we don't benefit our patient, we should not harm them. We should give them something harm, something give him a more microplastic. They already taking microplastic, and there is a global awareness about this issue. So we should contribute to this awareness. We should making every step, uh, uh, make a lot of attention for this issue. So as we know, the printed material is not fully cured after it is printed from the 3D printer, and we should pay attention for the post processing, which is cleaning and curing, which making the material completely biocompatible. If we see, there is a comparison between the resins and composites we use in our direct restoration, and still the printed composite is lower than double bond conversion rate. Uh, yes, printed crowns may be more than composites, but still under the double bond conversion rate, which give us a conclusion. It is a biocompatible material which we can use with confidence in our mouse, in our family mouse, and of course for our patient. Uh, let's discuss some clinical cases uh, for 3D printed hybrid ceramics. This is glass ceramic, fractured, overlay, taking it out, checking the occlusal clearance, taking a scan. The next step you can design by yourself or a designer, yes, or by AI. We should give attention for the designing by yourself or your by designer, the thickness of the material, the parameter of making a bridge. We should pay attention a lot for the length of the connector because the length of the connector is very or more important than the width of the connector. To make the oval design of the connectors, there is a lot of designs we should pay attention for, but it's more similar to designing for any other material, nothing specific for hybrid ceramic or printed ceramic. But the most interesting part is that the scanner company or the printer company like Shining 3D give us the option of uh, AI designing. AI designing or even not a AI, a normal person design in the platform. But the most interesting thing in AI designs, it is more cheap. It it costs you less time, and it only like 1 2 minutes. The AI give you the design for single right now and for posterior. Maybe later it may be become for anterior. I think it will be the second step. Third step maybe for bridges as well. So after you design and you pay your credit, it's very cheap, very affordable design software. You upload your STL for designing. After design, it give you you can control the parameter if you want to this design for the printer or for mailing, and then give you the option to modify whatever you want in the AI design, and you can support the STL file, or if you had the Shining printer hardware system, it already linked to Acquire to send already the design for your printer automatically, making nesting automatically. You just click print. It's a very easy way and very convenient way for us in busy clinic to just make a preparation, take a scan, and everything is automated afterward. After that, you just uh, approve the steps, you agree with the design, okay, then you want to print right now, okay, just few clicks. And it gave me the final crown. It is designed by Shining 3D Aquare AI design. Then we can, of course, in the end, it will be glazing. This is a mechanical cleaning by using glass bed. As I told you, glass bed surface cleaning to remove the superficial uncured layer. And of course, cleaning the preparation itself. Also, rubber dam isolation and the cleaning by Borosi powder. After cleaning the preparation, isolating the neighboring teeth, applying bond for both the acid etch the enamel, of course, then applying bond for the preparation and for your crown as well. I strongly recommend using the Bristol bond brush type, not the micro brush. Why we use the Bristol? Because there is a lot of publication about the remnant of the microplastic in our restoration and our teeth. We don't want to make a contamination. We want a clean bonded surface. So after cleaning, we can use whatever you want, highly filled, flowable, resin cement, or or you can use a heated composite as well, whatever you want or comfortable for. But my recommendation, if you select to use the heated composite, you should little bit increase the cement gap. Cement gap for normal highly filled flowables or cement resin should be about 60 micron. But for heated composite, you should increase this value, maybe for 100 micron cement gap. Okay, this is seating our restoration using a glycerine also around our restoration for the final cementation of our restoration. Finishing, there is nothing special like glass ceramics, like composites, like direct, like anything else. You can use carbide bear, uh, 12 flutes bears, you can Arkansas, you can discus, you can use abrasive strips. It's my favorite items I use for finishing my restoration, reciprocation, handy piece, of course, 12 blade, scalpel blade, of course, it's very beneficial for me to remove the excess cement. Like in this video, the reciprocation handy piece give me control to remove the interproximal excess cement without making injury for the neighboring teeth. Arkansas tool, 12 carbide pairs. It also give us a very nice finishing for our restorations. So after finishing, we can go for polishing. Polishing, we can use two-step rubbers. Mm, For the final polish, we can use the super buff or any impregnated diamond-based impregnated uh, uh, soft soft pairs. So another case, and it is very interesting for the application of the hybrid ceramic in our restorative daily workflow. What do you think of this crown? Yes, let's remove this old crown to see. What do you think? It's very subgingival margin. Curious. Yeah, I will not argue with you or uh, not be different from your opinion. If you told me just remove it and make implant, yes, I agree with you. But sometimes in our technology today and our knowledge today, we try to save at maximum as we can. And I will show you how the technology and the 3D printed helped me as a lot to restore teeth like this. Okay, we can you make isolation, of course, for this situation after removing the caries with Teflon. No way to try rubber dam for this situation, but Teflon make for us a very nice isolation in situation like this. Just we take a scan and we make a printed hybrid hybrid ceramic crown and post, or crown and core, or post and core alone, or crown into crown, whatever you want to call this design. You wanted to call it crown and post, okay, crown and core, okay, into crown, okay, whatever. But the it's one unit, monolithic, post and crown. So, of course, after doing retreatment for the endo, we can now make a margin elevation. So after margin elevation, we make the endo, we make isolation now. Then we take our scan and make cementation, as you see in the upper right corner, cementation of our post and core. Cementation video with resin cement, dual cure. After making cementation and removing the rubber dam, this is the result. But of course, we need more furrow for the final restoration. So we make uh, uh, make preparation, vertical preparation without vertebrae, without finish line. Then we apply attraction force by also extrusion of our restoration. We make also extrusion from the post and the from post and the core hybrid ceramic 3D printed one. Okay, you can imagine we extrude from this 3D printed hybrid ceramic restorations. After only 1 week, sometimes maximum 2 weeks, you can see the extrusion what happened for our premolar. Now we can refine again our uh, preparation, taking a scan. You can see how much we gain in the ferrule. This material is this tooth natural tooth structure is more than enough for us now to make the final restorations. You can see the steps in the X-ray, the endodontic treatments, the margin elevation, the endo, then scan and making uh, the hybrid ceramic Boston core extrusion and making the final crown. Parameter uh, of the preparation for the final monolithic zirconia crown. And this is the final result. Of course, we can do the same technique with metal, post, composite, but everything is more easier and more predictable now with hybrid ceramic printing, 3D printed. It takes nothing in our clinic and more predictable, in my point of view, to use a monolithic material as a post and core, not to make a material with post metal, and it is not um, a 3D anatomical for the root. It's only a stock shaped, which is round and full of material, of cementation material around this round post. Remember the initial situation and what we can get from the restorations. Another case, the same protocol we applied a lot in many cases, hopeless situation, completely hopeless situation without any millimeters, with zero ferrule. So we make uh, initial uh, isolation with Teflon, like margin elevation. Then we take a scan. We design a post and core with extension, not like the previous case with bottom, orthodontic bottom. No, in this case, we design the bottom and the bar inside the hybrid ceramic restorations. We design everything in one piece. Then, after we cementation, we make the same protocol, orthodontic extrusion for this premolar. After 10 days, sometimes 2 weeks at maximum, we get the maximum filler we want, steps in X-ray, and we get a nice filler, very nice filler. Then we make another hybrid ceramic temporary crown for tissue maturation, and after 1 month, we take the scan for the final zirconia crown. This situation, this is before. So 3D printed hybrid ceramic restoration in one appointment and extrusion in the same appointment, not uh, not like another technique of casted post and core, or not like not custom solution like making a stock post and composite build up. So this is the initial situation, and this is final situation. What about this case? I will go through um, the lecture because of time limitation. Yes, it has a fractured lateral. We make an implant, we make crowns, temporization, but the patient asked for the anterior with um, because of discoloration. You can see the lateral is implant, the central is has a caries and the discoloration preparation, and hybrid ceramic laminate. We use in this case CBD12 from Shining 3D. I like this material for anteriors a lot. The color stability and the color um, of this material is amazing. So finishing, polishing, cementation with opaque resin to hide discoloration of the uh, two central. Prophy is the same step as show you before, finishing with reciprocation hand beads, polishing, the same protocol as we see before. And this is final result of hybrid ceramic veneers for this old lady. It's a very perfect solution and affordable one, of course. This is before and this is after. Okay, partial restoration, like for this lady, plus 5 composite. Yes, we can do it direct, but as Francois Dugas told us maybe 40 years ago, good indirect is far better than anything direct. Insulation with Teflon and printing a class 5 restoration with holder to guide the position, removing excess and curing. What about pediatric? This uh, young girl come for my clinic. Yes, need anterior crowns, need posterior also. We take a scan. We design a hybrid crown, specific hybrid crown, not using a stock zirconia crown, which we can use and try the size. We use a customized crown for hair. We print the crown. We print a guide to hold this crown, and so we can cement the crown at once. Uh, Not like the regular technique we cement crown by crown. No, we will cement the four crown or the six crown. In this case, is four only for anterior crown at once. So this is the printed hybrid ceramic. I think this is the first girl all over the world to receive a CAD CAM hybrid ceramic crowns. I didn't hear in application. I didn't see any other colleague make something like this. I invite you to try with me if you want. I can help you to implement this technique and to become this normal for the pediatric because, in my opinion, it reduces the time of anesthesia a lot. If you cement four crown at once or six crown at once, how can you imagine the reduction in the anesthesia time? How can it imagine? It is a patient-centered approach. And what about using zirconia, which is more stiff crown, or using a hybrid ceramic, which is more suitable for the lifespan we want for this crown to last in our pediatric patient. Anyway, after preparation with the cleaning and in the general anesthesia, trying the stent and cementation of the crown at once. This is before, this is after. Another case, looks like I prepared a lot of cases for you. I will go through more quickly. Preparation, endocrowns for this case, like before, printing using Shining 3D. This is the endocrowns. Endocrowns. One appointment dentistry it is not more reliable than this time with 3D printed and with reliable technique, reliable step, and with good results. And this is the final result for the patient. Implant. I use for implant as a temporary or a long-term temporary, not like restoration. For restoration, I use it as a permanent in the cases I show you. But for implant, like an immediate loading, we make immediate loading with hybrid ceramic as a long-term restorations. And after, there's a picture of our temporary. And after 3 months, we can see how beautiful our soft tissue, how it is biocompatible material, and how biocompatibility of our product, no inflammation, no bleeding, nothing, and we can take the impression or scan easily for the final restorations. This is a follow-up of our final restorations. And at the end, I want to share with you some prospect about the future of dental 3D printing. The future of dental 3D printing will be biomimicry and bioprinting. And what I mean by biomimicry is biomimics the natural organism design or the natural organism mechanism. So like in denture, we can design a complex geometry in the anterior surface of the denture, uh, like octopus circles, which definitely will improve the retention of the dentures. Of course, these designs or complex designs like this is difficult to manufacture with a subtractive technology, which is milling, and of course, will difficult by the normal analog manufacturing tools. Also, like micropores in the zirconia abutment. In the printing zirconia, we can include a design of micropores in the subcritical zone, so we can gain a horizontal attachment of the potentium into the abutment. And as you know, we lack in the dental implant procedures this type of attachment, which is horizontal. We only get the vertical attachment, and of course, presence of horizontal attachment to the potentium between the potentium and the dental implant abutment will protect the implant from food debris or from pathogens or dental plaque. Also including a mesh or micropores in the anterior surface of the printed zirconia will enhance the adhesion properties of zirconia and extend the application of the dental zirconia to be designed and to be used for anterior dental veneers. Also, biomimicry of tooth or root analog, so we can make segmentation for the hopeless teeth and design a root analog either from zirconia or from titanium. So after extraction, we can use the same anatomy of the extracted tooth by implant design, resembling the natural tooth morphology. And biomimicry also in the bilayer printing, and what I mean by bilayer printing is different consistency of the material in the printer, and the outer layer will be more stiff to withstand the force, but the intermediate layer will be a cushion design like this. So there is be a spaces between the layer during the printer design. It will resemble the tooth movement during function, which will be around 100 micron. So with this design, it will be very beneficial for dental implant procedures or to connecting the natural tooth with the implant. Uh, like in this video, the ground is very stiff from outside and inside, but in between there is a cushion layer, which is like resembling the tooth periodontal ligament mobility, give in the end the same uh, degree of mobility. Bioprinting, either by stem cell printing itself, and we can see a publication about printing kidneys, about printing heart for rats or cornea, and or biomaterial scaffold from biocompatible material. Then this scaffold material is implanted under the skin or under the muscles uh, of the patient, the same patient. So after some time, it will grow up vital cells in this scaffold. We can take off this organ again to be transplanted for the same patient in his nose or his ear. Um, so it will help the reconstructive surgery a lot in the organ transplantation. So at the end, my home message is 3D printing offer promising laboratory and clinical outcome, optimal printing and post-processing and appropriate design for restoration are the key of clinical success. 3D printing resin is readily available for different clinical application if the fabrication steps are thoroughly followed. 3D printing future of biomimicry and bioprinting is coming so soon. Thanks for your attention. Thanks, Shining 3D, for giving me opportunity to share some of my knowledge with you. It will be my pleasure to keep in touch through my social media, Instagram or Facebook, to share cases, to share opinion about your feedback. And I wish you all a good luck. Bye bye.